Thank you, Richard, and thank you to the Men's Shed for allowing me to come along here. This is a subject is a passion of mine. Can everybody hear up the back? Okay, good.
I can't hear.
You can't? Okay, okay. I'll try and talk a little bit.
Yes.
Okay. Right. How's that?
Much better. Thank
Okay, good. Now, I'm also going to try and use this little device here. Can people see that little red dot?
Yes.
You can see that? Okay. And this is a new little device that allows me to control the computer there. I've decided to write this presentation because even though most of us have a whole lot of issues that we're concerned about, we have worried about personal issues, we're worried about pandemics, economic issues. There's a lack of understanding or awareness in the general population about this issue and how serious it is. And even though we hear about certain things that are happening, like we hit bushfires and floods and things, to understand, I believe that if we understand the causes of it and some of the implications of it, if we're better informed, we're going to make better decisions. Now, this is a basic guide to what the scientists are telling us. I'm personally not a scientist, and I'm not part of any political party, but I have done this out of concern for my grandchildren and future generations. This is an issue that may not affect us sitting here, but it certainly is going to impact on future generations. So science is a process of gathering data, getting ideas together, testing theories, perhaps writing very sophisticated computer programs or models, and then publishing papers which are then peer-reviewed by other scientists. And every so often scientists come together and collectively put their work together, and they come to a consensus on what's happening. And the vast majority of scientists working in this field do agree that the climate is warming and the cause is human activity. And I can tell you that there is a lot of frustration and anger in the scientific community that this issue is not being taken more seriously. And the concern is that if we don't do something about it, then, and to restrict temperatures from climbing too high, then life on Earth will become very difficult, and it will affect human health, and it will affect the whole world. So, and I want you to know that in this is not about the weather, wet weather, it's not even about seasonal weather, it's about long-term trends. First of all, we should understand how the climate system works. Here's a graphic which shows the Earth, the atmosphere around it, the sun up in the top left-hand corner. Now, in the atmosphere, mostly made up of nitrogen and oxygen, but in that atmosphere there are there's small amounts of these so-called greenhouse gases. The main one is carbon dioxide, CO2, which comes from burning fossil fuels, and the other is methane, which comes from animal digestion or decomposition. Even though there's only a small amount of them in the atmosphere, they play a very important role in what's going on. Because if you'll notice here, we get visible light coming in from the sun. Some bounces off the clouds, some bounces off ice and goes straight out into space. But a lot of it's absorbed by the ocean, land, and then in the process, particularly at night time, heat radiates back out into space. Now, in pre-industrial times, the small amount of these greenhouse gases captured just enough. They have this ability to absorb this radiant heat. It's sort of infrared, in the infrared spectrum. So these greenhouse gases can absorb that heat. And in 4 here, oops, sorry, getting this ahead of myself here. Here, you'll find that just enough, what has happened over thousands of years, just enough of that heat is retained in the atmosphere to keep life on Earth in a sort of Goldilocks zone, where it's not too hot and not too cold. So life has thrived in this very benign environment. What's happening now, if you look on the right-hand side, human activities, burning fossil fuels, clearing land and animal production has increased these greenhouse gases. So that means that there's more heat is being captured in the atmosphere and it's being trapped like a thicker blanket. So this is causing temperatures to rise. So there's a direct relationship between these greenhouse gases and the level of them and the amount of temperature. So that's the first important thing to understand. Now, let's first look at carbon dioxide. Now, this graph goes back 400,000 years. In fact, scientists have dug ice cores in Antarctica and up in Greenland, where they've gone back 800,000 years. So they've drilled like a kilometre into the ice, and they can measure how much oxygen and the different gases that are trapped in the ice from the previous ages. The interesting thing here, you'll notice, is there's this cycle up and down. This has been going on for hundreds of thousands of years. The reason for this is that the Earth, in its orbit around the Sun, is not a pure circle. Over tens of thousands of years, it slowly pulses away from the Sun, and the Earth gets cooler. So, and then it comes back. So there's a cooling period. So here's cooling period into an ice age, a warm period, cooling. But what I want you to note here is that in all this time, right going back 800,000 years, carbon dioxide has never reached above this level. This is us here. Okay, so we've gone from almost, this is the normal cycles of the Earth going on. This is us impacting the levels of these greenhouse gases. Now, let's move on to the carbon dioxide. This top part of this is the same as the previous one, and you can see it taking off like a rocket up. Whoops, sorry, taking off like a rocket up there. Now, watch how temperatures follow carbon dioxide. They both move together. Right over here on the right-hand side, you'll see we're down here in the last ice age. Here we are in the Holocene, and this is called the Anthropocene, the age of the humans. So we're getting this, what is happening now is this temperature is starting to take off, caused by this rise in carbon dioxide. This graph was done by a fellow called John Englander in America who studies sea levels. You'll notice sea levels go up and down with temperature. And I'll explain more about that later, but there is a direct link between the amount of ice that's trapped and sea levels. But the scary thing about this graph is that here we are in the last ice age, and here is us now. That difference in sea level is 120 metres. 120 metres. It's just massive. So that's the sort of change that you see long term. Now, let's have a look at temperatures over the last 10,000 years. This goes back into the last ice age. Here we are. Aboriginals were wandering around Australia. They lived through an ice age. And then about 12,000 years ago, through natural events, the Earth started coming out of this ice age period. And we came up to what is the long-term average. So we've got to remember that we're not talking about daily fluctuations or annual fluctuations in temperature. We're talking about an average temperature of the globe in the atmosphere at any one time. So the average all over the world for the last 10 years has been about 15 degrees. That's that horizontal line there. So temperature started rising, and then it kicked back in a thing called the Younger Dryas. Now, if I get a chance, I'll mention that again later. A little kickback there, but then temperatures rose over a period of 10,000 years to what we call our long-term average. Then during, as you may remember, the agriculture flourished in the Middle East, and then there was a period in the medieval time, a warmer period, when the Vikings started moving about, moved to Greenland and America. Then there was a little ice age in Europe, and you may have seen some of those old paintings of frozen lakes and rivers in Europe. And then it was fairly constant until middle of last century, where it's just taken off. Now this graph is called a log scale, so it's squashed up at this end. But that dotted line up there is a band of temperature rises that we can get to depending on the amount of greenhouse gases we're allowed to get into the atmosphere. Now, I want you to note this: the difference between here, when Aboriginal people were wandering around quite happily, and the long-term average is about 4 degrees centigrade. Now we're going for 2 degrees in 200 years. So that's the scale of the difference between what's happened naturally and what we're doing. 2 degrees or more in 200 years. Let's look at us in the recent years. I was born back here in the Boer War. No, I wasn't. I was born somewhere around here. Temperatures. Now the blue line, the jagged blue line, are temperatures. Now you notice they're jumping up and down. In fact, when I was born, after I was born, temperatures were fairly even for a while. Since about the 1970s, they've taken off, and they're up now. 2016, 2020 we're up about 1.2 degrees around the world. Australia is up about 1.5 degrees. So it's not even around the world. The Arctic is about 3 degrees rise. But these jaggeds, the cause of this jagged is things like what we're experiencing now, La Nina, when it tends to be cooler. El Ninos, when we have the bushfires, that tends to be hotter. And these events cause temperatures to jump around a bit. Volcanoes can affect temperature by throwing a lot of particulate matter into the sky, which stops the radiation coming in from the sun. Now, look at temperature and carbon dioxide in the recent times. Here's a graph showing that blue jagged line is temperatures climbing up from 1880 up to the present. Carbon dioxide. So you can see from that how they're moving together. So it is interesting to note that just a couple of things, that of the extra heat that is coming into the Earth, most of that heat is being absorbed by the oceans, almost 90%. So if the oceans hadn't absorbed a lot of the extra heat, the air temperatures would be far warmer than they are. Whereas with the carbon dioxide, most of it remains in the atmosphere, and some goes into the ocean and some goes into trees for photosynthesis. Now, I want to talk to you about the consequences of these changes. And scientists, this is the sort of cutting edge of science at the moment, and there's a lot of debate and work going on in this field at the moment. Now, the IPCC, which is the International Panel on Climate Change, has defined a tipping point as an abrupt and irreversible change to the climate system. Now, what they say is that we have a budget. We have a budget of how much greenhouse gas we can put into the atmosphere before we get to serious consequences. At the moment, scientists are looking at a figure of 2 degrees above long-term average. So again, it doesn't sound much, but fractions of degrees matter when you're discussing this. 2 degrees, above 2 degrees, they're talking about serious changes to some of our systems, environmental, ecological systems, which could tip into a state where we can't bring them back. Now, and these, as I say, are not going to happen overnight. They're not going to happen in our time, although to a certain extent, some of these things are starting to happen already, as I'll tell you. Let's look at number 1 in the Antarctic. Oops, sorry. Wrong button. In the Antarctic and up in Greenland, there's massive amounts of ice. So when the glaciers break off and fall into the sea, or as in Greenland when glaciers are melting, sea level rises. Also, the extra heat that's going into the ocean is when liquids warm up, they expand. So the oceans are actually expanding. So there's ice melting and there's expansion. See, in my lifetime, sea levels have risen like 18 centimetres. So by the end of the century, they're talking about a rise of between 0.6 and 1.1 metres rise in sea level by the end of the century. So that's when my grandchildren could still be alive. The next thing to look at is coral reef. Unfortunately for us in the world, it looks like the barrier reef will not, if we get to 2 degrees, the barrier reef is most likely to die. It's starting to happen now. We're already seeing coral bleaching, quite a frequent event in recent years. And we've only got to in Australia, 1.5 degrees. If we get over 2 degrees, there'll be such, the waters up there will get to an extent, the temperatures will rise to an extent where the corals cannot survive. And right through the equatorial zone, there's millions of people who depend on coral reefs for their existence. Up there in the right-hand corner, permafrost. You may have heard in the Russian Siberia, the tundra there. Now, the tundra was laid down before the last ice age. There were massive forests right through the north of Russia, which then temperate rainforest, temperate forests, which then, when the ice age came in, they died. They laid down this massive amounts of carbon, a bit like peat, and they were frozen in ice, and they've been frozen in ice, and they're still frozen in ice. But what's starting to happen now, is that the temperatures are causing that ice to melt, and air is getting into that peat, and it's decomposing, and we're creating methane. Now, as I said, methane is a product of decomposition. Unfortunately, methane is about 30 times as bad as carbon dioxide as a greenhouse gas. There is so much methane locked up in Siberia that it could cause devastating effects for the entire world. That is quite a scary prospect. As I say, it's not going to happen immediately, but long term, that methane trapped in up there is worrying scientists. Right across the top, just a minute. Okay, right across the top here, boreal forests that go from right across the top of Russia, top of Europe, right across America. About a third of the world's forests are pine forests, or this zone up in the Arctic zone. And these act as what we call a carbon sink. So as you know, the process of photosynthesis, they absorb carbon dioxide in the process of turning into new growth. These forests are massive carbon sinks. Unfortunately, we're starting already to see wildfires that have never happened up there. And if the temperatures rise enough, we get enough wildfires, then these forests will die. So unlike the Australian eucalypt, once they get a fire through them, they die. That could turn into savanna, so that the forest will retreat north. We're going to have more savanna, more grasslands, and that means less of a carbon sink. Similarly, in the Amazon, here, the Amazon rainforests have always been an absolutely massive carbon sink. So all that growth there is absorbing carbon dioxide. In recent years, the Brazilian government has allowed huge amounts of deforestation to occur because of for cattle breeding and growing soybeans. There's about 17% of the Amazon rainforest has now been cleared. The scientists believe when they get to a sort of 25%, that turns into savanna, then we lose, instead of being a carbon sink, it's actually going to become a carbon emitter. Now, let's have a look at here. So I want you to note that with all of these events that I'll describe, you can't say that a particular event is caused by climate change. But what you can say is that climate change is affecting the conditions under which natural events happen. So there's things. Oops, sorry. Keep pressing the wrong button. Now, the southeast and the southwest, they predict are going to get drier. The north, going to get wetter. Because of the increased heat, and we saw this 2019-20, increased bushfires. Bushfires will become more intense and more widespread with a drier climate and more heat. And then we're going to have cyclones. Now, because the ocean is warmer and the atmosphere is holding more moisture, because every 1 degree is like 7% more water held in the atmosphere. So events like cyclones will become more intense, coming into Queensland, coming into the northwest. When we get events like we did in March, when we have a natural we go from a La Nina, from an El Nino to a La Nina. When we get these rain times, they will tend to be more intense, and that's what we're starting to experience already. The barrier reef, as I said, will possibly go. It's going to affect seafood production because of the warming climate. Then the thing that does concern strategic thinkers, people in the military, is that because of the massive changes that will happen in Asia, where people are displaced through flooding and temperature, they will tend to want to move, and they're concerned about mass migration of people. There'll be extinction of flora and fauna because of the heat. Insurance premiums are going to go up, and probably the biggest cost is going to be the cost for us through our governments in adapting. Think of Lismore. We might have to move towns and cities because of the rising sea levels and extra flooding. Now, okay, so let's just have a look at where we are at the moment. This is the latest projections from the IPCC. So, as I said, we had a target. So the IPCC, they have these meetings, and they call them COPs, Conferences of the Parties. You might remember there was one in Glasgow last November where our Prime Minister was dragged off was forced to make a commitment to the IPCC. But they have these COPs. Now, the last one in November was COP26. In COP21, which was in Paris in 2015, the parties to that agreed that we've got to do what we can to hold temperatures between 1.5 to 2 degrees. 1.5 degrees is almost impossible. Well, we're almost there now. 2 degrees, a lot of people are saying 2 degrees is definitely going to be breached. But this was the aim. Paris targets between here and here. Right? These are temperatures. Now, this is us where we've got to so far. And depending on the amount of emissions that we're allowed to get into the atmosphere, low emissions will hold temperatures down, mid-level emissions, high emissions, 4 degrees. Forget about this because that would be catastrophic. So this is another way of looking at the same thing. It's a bit more complicated, but this one down the side here has carbon dioxide. So as I say, the scientists talk in terms of budgets of how many gigatons of carbon dioxide we can push out into the atmosphere. So carbon dioxide levels have gone up here since they're climbing here. To get to our target, 1.5 degrees, we've got to start, there's 2030, we've got to peak at 2030 and just try and get out this graph to drop down here. Now, what's the pledges made, so at the Paris Agreement I did mention, every country was asked to say what they would do with their emissions to achieve this target band. And these are called nationally determined contributions. They're non-binding. They are just statements of, we will do this by 2030, we will do this by 2050. So these NDCs, this is what the pledges made to Paris were, to get us to 2.1. Unfortunately, what's happening is that countries around the world are not keeping to their NDCs. The current policies and actions are getting us well over 2 degrees. So that's the current situation. And how does Australia fit into this? Well, unfortunately, we don't show up very well on this matter. We pledged a 26 to 28% reduction in greenhouse gas emissions by 2030. Most countries have doubled that, and our government refused to increase that amount. Our levels have been described as insufficient, and the Secretary General described us as a holdout. Our per capita emissions and our policies are regarded as about one of the worst in the world. So our achievements and our policies are just not up to where they should be. And when I look at this, I am frustrated that, as I'll show you in a minute, Australia has the easiest path to achieve massive reductions in emissions, the easiest path of entry any country in the world, and yet we have the worst policies to achieve. And unfortunately, that's where we are. But generally speaking, I do worry about countries like China and India and Southeast Asia. They have massive populations, and to try and achieve these targets is going to be a big thing. But for Australia, as I'll show you, it's an easy task. Now, what are the solutions? The thing that has changed the whole debate has been the price of renewable energy. Mainly solar panels and wind turbine prices have just plummeted in the last 20 years. When my wife and I built a stone house up in Foxground in the 70s and 80s, we lived off grid. We could afford one small solar panel like this. I think it cost us $300, and that was enough to keep one light going. Now that was we were paying about $100 a watt. That's the price of a panel. This is, if you're buying $100 a watt, We're now, that's 61 cents, we're now 25 cents per watt. That's the manufactured price. So that's, you can see how those prices have just plummeted. And this largely is thanks to work done at the University of New South Wales. The team there, back in the 70s and 80s, were working on new technology for solar panels. And one of their team, a young Chinese scientist, went back to China and started making panels and became the richest man in China. And China is now responsible for dropping these prices down. Conversely, solar panel installations have just skyrocketed, as you see on so many houses around here. And so these are the differences now between, so renewable energy from solar and wind has now become so cheap that it's far cheaper than coal-fired power or gas-fired. Here down the bottom you'll see utility, large-scale solar, 3.7 per kilowatt hour, wind 4.1, coal-fired 10.9 cents for a unit. So that's the difference that's just totally swung in the other direction. Now, to see how this is going to work, this transformation that we're going to see, and we have to make happen, and in Australia we can make it happen really easily, is that we're going to have to electrify everything. We're going to have to produce massive amounts of renewable electricity, wind and solar. So you've got wind farms, you've got solar farms, you've got pumped hydro feeding renewable energy into the system. And in some countries they'll be using nuclear power, but in this country I can't see nuclear power ever competing because we have such fantastic solar resources. Nuclear will probably never come to this country. The other thing that's really important is that when you have these renewable sources, they have to be reliable. And you've heard the old argument, oh, what happens if the wind doesn't blow and the sun doesn't shine? So we have to have batteries, we have to have backup. Now this can be done in several ways. And right now this is a diagram of Snowy 2.0, which you've heard about, which Malcolm Turnbull started. What they're doing is building a set of tunnels from one dam, well, keep doing this, a high dam down to Talbingo, and there's the pipes, and there's a power station and pump station here in underground. When the wind's blowing or the sun's shining, they'll pump water from this dam up to here. Now that's energy that's held there. So when people come home and there's a demand for, they turn on their air conditioners and there's a demand in Sydney and Melbourne for power, or if there's a storm comes across a solar array and it drops, this can kick in and start producing power by running water back down. So we could have these small versions of this all over the place. There'll also be, you might have heard of the lithium batteries. There's one in South Australia that was built by Tesla. They play an important role in keeping voltages within a band. Now, it's important when you receive your electricity that the voltage doesn't drop too much or peak too much, because it can blow machines and that sort of thing. These lithium batteries stand in the middle of the system, so somewhere in here, before you can have lithium batteries somewhere in here, so that if there's a sudden drop in power, they can kick in for a while to bring the voltages up. And then, of course, on top of all of these batteries, the big ones, we're going to have household batteries. So people are going to have household batteries which will be connected to the grid, and you will be able to sell that excess power back to the power companies at peak time, and you'll be able to get good money for it. So this is so that there'll be arrangements where you can sell or take in power with your own household batteries. Now, the other part of this transformation that we're going to have to do, and we're starting to happen, is our power grid. We have this massive power grid around the East Coast. And as you know, we have coal-fired power stations in Queensland, in New South Wales, Victoria, and there's this like a spider's web of transmission lines that go to the cities and to regions. What's going to happen is that all these green diamonds are new renewable energy hubs. So these are windmills down in South Australia, you'll see them if you drive around there. There's hydro in Tasmania, there's windmills in the Bass Strait. For example, there's one bauxite, one aluminium smelter in Victoria, which takes 10% of Victoria's entire power load, is one smelter. That will be powered by wind power in the Bass Strait. And then all of these solar farms will be connected into the grid, and there'll be high transmission lines so that power can be pumped from one part of the country to the other. So if there's a deficit in one area, there'll be supplied from somewhere else. I'm not sure if this link will ever be done, because we might find Western Australia's going to do so well out of this transformation, it might secede and take off on its own. Right, so what's it going to do for our homes? So here's the home of the future. We're connected to the grid. There's going to be a household battery, solar panels on the roof, household batteries. Everyone will have an electric vehicle charged at home. There'll be, your cooking will most likely be induction stoves, which are super efficient. Your heating and cooling will be what they call heat pumps, which are reverse cycle air conditioning, and the water heat will be from heat pumps. This graph, this diagram, it just gives you an idea, if you just bear with me. This is, on the left is the average Australian home now, conventional, where we are now. This is an electrified home. The biggest use of fossil fuels in the average Australian home is vehicles running petrol, diesel cars. And then we use electricity for space heating, cool water heating, that sort of thing. This part here is generation waste, because the big coal-fired power stations lose about 60% of the energy that's in the coal in those big cooling stacks. So they're quite inefficient. So this is our current situation. The total in terms of kilowatt hours is about 100. So now, if we go electrified, electric vehicles are hugely efficient. So petrol diesel vehicle is about 25% efficient. So that's only about a quarter of the energy that's in the fuel is transmitted into motion. Whereas an electric vehicle is highly efficient. They lose about 5%. So you can have vehicles. You'll be charging your vehicle, which will be very efficient. There'll be, all these uses will be more efficient appliances, and we don't have any of this fuel, and we don't have this waste in the generation process. 102 down to 37. And in terms of dollars, somebody calculated that for the average Australian house is a saving of $5,000 a year, which I think is significant. Okay, so what we can do as a country, this is specifically Australia, what we can do if we have plentiful renewable energy. So we're going to replace all our transport vehicles will be electric. We spend $40 billion a year buying in fuel from Singapore, and we have almost none here in reserve. So that's going to save, that's $40 billion, and by the way, that is less than the profits made by people who are exporting coal and gas. So we're going to save that. Everything will be electrified in the house, so people have a better lifestyle, cheaper. Aluminium, I mentioned before, bauxite. Now at the moment we process some bauxite into aluminium, but with renewable energy, it's an electric, it takes vast quantities of electricity. With renewable energy, we will be able to just export aluminium, and the value of that will be 3 times what we have currently. Steel, now you know Twiggy Forrest is talking about steel production, and that's going to happen in the long run. So using hydrogen from green hydrogen, that's, I'll mention this in a minute, green hydrogen and electricity to make raw steel, exports possibly 10 times the value of the iron ore that we're now selling. Those are big numbers. Hydrogen made by electrolysis, so you put an electric current and say renewable energy, green, I'm not talking about blue hydrogen which is made from gas. Hydrogen comes from electrolysis, oxygen, hydrogen coming off. That hydrogen is captured and could be used to make ammonia, so which is used for fertilisers, and also cement. Cement production it takes a lot of energy, and so ammonia could be used in that production. We could. There's a group up now looking at a project up in Northern Territory. This huge solar array covering hundreds of hectares is going to be joined by a cable to send power undersea, a high voltage cable undersea through to Indonesia and Singapore. That's the sort of thing that we could do, because we've got, Australia theoretically has enough solar energy to power the world, but theoretically. The technology that we could develop, if we're a smart nation, we could actually export that into Asia and assist developing countries to transform. New energy, new industries will become here because of our cheaper power, and jobs. People go on about jobs. We can have jobs in rare earth mining, installation. You can imagine transforming every house in Australia to an electric house. Hundreds of thousands of jobs in manufacturing. So those are the sort of things we can do. Now, as an individual, some of the things you can do, if you can afford it, solar panels, definitely worth it. So batteries are still a bit expensive, but the prices are dropping, and soon they will be at a price where they can definitely benefit you, particularly if you have a larger family. And if you think about fuel consumption, then you might look at an electric vehicle. Electric vehicles by possibly 2025 will be on parity with petrol cars, much more efficient. Community solar projects, you know the Shoalhaven's involved, Shoalhaven Council is already involved in them. That's a case where you could have a factory or a school covered in solar panels with batteries which can feed power to the surrounding community. So everybody joins in and you get the benefit of a collective solar setup. And that's good. And there's a couple in the Shoalhaven Council exactly buying people from a community. Shoalhaven is buying power from a community solar station. Plant trees, the political process, well, I'm not going to comment on politics, but I think we should all be thinking about, at this time particularly, who we believe is going to do something about this issue. And you can talk to the members and that sort of thing. So the conclusions, right, consensus that climate's undergoing warming over natural variability. Carbon dioxide is the cause. If carbon dioxide goes up, temperatures will go up. And there is a potential danger to the human welfare and the environment. Now, these are just a few of the things. The federal government is the body which could do the most to get this process going. So they've got to listen to the science, but we've got to set higher targets because we can do it. We've got to have policies. We've actually got to have policies that are quite clear for business and for everybody to know about. The states are doing quite a bit on this issue. It's the federal government which is the laggard. So incentives, it doesn't have to be budget just pouring money into it, because if you read Ross Garno down here, Professor Ross Garno, brilliant guy who advised Gillard and back then, he's talking about underwriting loans to private enterprise to put in new power lines and new infrastructure. So they're just guaranteeing loans and that sort of thing. So there is a lot of concern. There is a lot of concern. We need to act more urgently. So this is a pressing issue. It's the biggest issue. So we've got, as I said, we've got so many issues confronting us. This is the big one. It's creeping up on us, and it is a serious issue. If we procrastinate and kick the can down the road long enough, it will be more costly and difficult to adapt. Adapting to what's going to happen to our infrastructure and everything, the longer we put it off. Solutions are achieved. We don't have to wait for the technology to come along now. There will be new technology, say in battery development, but we have it. We have it now, what we need. Australia has an abundance of what we need, and we should be a leader, and we can be a leader. We have the most to benefit from this transmission. A couple of books, if you're interested. This one, Saul Griffith, I've read this recently, just out. Saul Griffith, The Big Switch. It's a revelation. If you want to read about the prospects and the possibilities for this country, get hold of that. If you're into economics, Ross Garno talked about superpower, how we could transform to become the superpower of renewable energy. And also, if you want to read a bit more, I've got a blog on a thing called Medium, Bill's Climate Science Basics on Medium, and I've got this sort of thing with more detail into it. So that's your blooming lot. So, thank you.
Thank you very much indeed, Bill. Certainly a topical subject, and one I think we should all know more about. And I appreciate the fact that you've taken the time to come and talk to us, to enlighten us on this particular subject. Bill's also got a brochure that we actually got in the mail yesterday, and he would have some of those and make those available. And it goes into quite a lot of information, more so than you can do in a presentation this morning. So have a word to Bill that he can make sure you can get one of those. We can take some questions, although we don't want to be here at 12:30, and some questions you can take offline directly with Bill, but we will take a couple of questions if people have something they'd like to raise at this point in time.
Bill, it's more of a comment than a question, I think. Australia seemed to politicise climate change and the challenges that follow more than the Europeans do, more than the British do.
Absolutely, absolutely.
It's no longer a political issue in most of those European and through Britain. It's no longer a left-right political issue, but it's lingered here as being one. And it keeps reoccurring as a political issue.
Yes, it's a most unfortunate thing. In my blog, I do write a little bit about the politics of it all in this country, and it's a most unfortunate story. But it has become quite toxic between Labor and the Nationals. Sorry, yeah.
You can be waved towards the mic, I think. No.
Sorry.
I thought John was trying to persuade you to go closer to the mic.
Oh, I'm sorry.
Sorry.
Can you, is that on? I'll come down here.
Testing.
Yeah. Now, yes, it is a toxic political matter in this country, and it has held us back for more than a decade. Unfortunately, as I said, to me, having read so much about this, it is very frustrating to everybody who's involved in it that, as I think I've demonstrated, we have massive opportunities because of this. Europe, as you said, Europe has taken the challenge and they're doing something. There's a setback now because of the war in Ukraine. But for us, it is quite easy. It is easy to achieve. And yet, if you looked at the current political debate, there's almost no mention of climate change in this election, which is, to me, very frustrating. And I do hope that we get, however it is, maybe some of these so-called teal people will get in, and because that's a big issue with them. Hopefully some of the young people who are engaged in this will come in and make changes, because it's something that we've got to grasp. I'm hoping that after this election there may be a change and we can start getting some policies which encourage this transformation.
Thanks. Did you want? Yeah, yes.
Rob, I respect everything you've said and I agree with it. And Australia has a phenomenal responsibility, but we're still very small. I guess what worries me at a much bigger level globally is the population. If you look at carbon dioxide, it's gone up with the population. Really, we should be trying to reduce the world population. Not only one person have I heard has spoken about that. That's Brian Schmidt from Canada. And also, we shouldn't be having lawns. We should not have lawns. We should not have grass. And we should all be vegetarians. But we've got to have some monumental personal changes as well as the technological ones. And I just want to throw that in for good measure.
Yes, absolutely. Look, you could say that even at a more basic level, population is the big issue, and particularly since I've travelled a lot I used to travel a lot to Asia and China, and you see this growing middle class who are people who have traditionally lived very frugally now want to have all the things that we have. They want white goods, they want cars, motorbikes, and that sort of thing. So there's this growing middle class in Asia, and you think, how is this going to happen? The fact is that I don't think we've got the opportunity to suddenly reduce population. We have to deal with a growing population. Hopefully the curve is starting to curve off a bit. The growth is not quite so high. However, there are opportunities throughout the world. If you think of India, massive population, but it has very good solar resources. And we could be involved with India, helping them set up. They've got millions of little villages which could become independent solar generators, and they could have a better lifestyle without than they have now. So we're going to have to. The whole world is going to have to be more creative, and it depends a bit on whether you're a pessimist or an optimist, whether we're going to achieve what we need to achieve. Because some of those graphs, if we don't do something, the future is really scary. If we talk 3 degrees or more, it is a very scary future for everyone.
Well, thanks very much indeed, Bill. On behalf of the Berrymen Shed, we'd like to present you with one of our world famous breadboards. Our maker is down the back row down there.
Oh, very good.
And we have given these breadboards to politicians, to lots of people. So on behalf of us, thank you very much indeed. Thank you for the talk. And if you want to